Welcome back, everybody. We're working on the Unit 10 COVID-19 graph assignment. In this assignment, which we sort of started the process last week, we're basically going to take a raw data set and then use Python programming to create visualizations of the data. This data set that we were tasked to use was the data set here in the third link in the assignment, which comes from the GitHub repository of all the COVID case data. And we determined, I think, that they stopped collecting data in 2022 or 21 or something like that. Although some people are still being affected by this pandemic, by the way. Then after you got the data and we looked at other people's visualizations and data repositories and all that, the crux of the assignment really is to create a program that plots the data in the format of your choice. So in other words, if you think a line graph is okay, or a scatter plot, or a bar chart, or whatever sort of visualization you think is appropriate, that's what you should use. Now, my suggestion would be for this type of data, because we're basically looking at numbers of deaths and numbers of cases, that a simple line graph is probably the most appropriate one. Just kind of putting that out there, or a bar chart, right? Because basically we're plotting XY points on the graph, and the Y points are like how many, and the X points are when it happened, like which day of the pandemic, right? And I asked you to plot both confirmed infections and confirmed deaths, because just because you got it doesn't mean you would die, right? But then a lot of people did die, and I'm sure all of us were affected. Either somebody in our families or friends or somebody we know was affected. And now, of course, they have other data points, including people claiming they have long COVID, where they have long-term effects from it. And then they have other data showing like how many people were affected who were vaccinated or not vaccinated, or, we had that whole dilemma. I don't know how much of the population got vaccinated, but I think it's somewhere in the neighborhood close to 2/3 to 3/4 of the people got vaccinated. There were a lot of people that didn't for various reasons, either because of personal choice or because of health reasons, right? So some people, their health couldn't support being vaccinated. Anyhow, so I'm not here to talk about the pandemic. In principle, it's over. I'm not so sure about that, but in principle, it's over. All right, so we want to see data for confirmed infections and confirmed deaths, a title that describes what's shown, labels for the X and Y axis, and a legend of the data, right? So meaning like, red is deaths, blue is infections, or something like that. And then format the graph so it's appealing visually and easy to read and understand. Now, if you were using Excel, this is a lot easier, right? Because you could, in principle, right, also process the data with Excel. And this is something I would actually maybe recommend that you do, right? Here's the why. If I'm going to plot this using Python and I get a result, how do I know that that result is really correct, right? Is that really what the graph should look like? So once you have your data gathered, it's easy to grab it, drop it into Excel, and create a quick little chart or graph with Excel just to see if, like, yeah, that kind of looks like mine. Okay, I'm all right. That's kind of my mindset on it. Now you might argue, well, why not just use Excel to do the work? Okay, well, there are a bunch of different reasons for that. Having programmatic control over data, in other words, you have the raw data and you can control exactly what the visualization does, is a little bit more powerful than working inside of Excel, where you're kind of trapped by the tools that Excel gives you, right? In essence, you're sort of trapped by the APIs of the tools that you're using in Python, but Python also has a number of different visualization libraries. It's not just Matplotlib, right, which is the main one that we're teaching here. There's many others, right? And they all have different features and tool sets and approaches to using them. And it is a bit of a learning curve to learn all of them, but it's driven by the necessity of your task always. It's the advice I give my students. All right. Otherwise, once we get all this information, so this is really the crux of what we're doing here. And then finally, we will basically take screenshots, submit the code, and then we'll talk about it a little bit too, right? Because so some of this is all about talking points, and the data sets are interesting. Now I'm going to click through to the data set just to pull it up on screen. And I know I went through this last time and probably in my downloads somewhere, um, and here we go. So I have like time series COVID-19 confirmed, and then I boiled it down to Racine confirmed cases, right? And confirmed cases are different than deaths, right? And so like if you're looking to get the data for one county or one state or one city, whatever your paradigm was, and I didn't really specify that it has to be for anything in particular, did I? Right? Yeah, I didn't say that it has to be for the US or it has to be global or it has to be Racine. I just started extrapolating on my own. And I think what I did is I ended up taking the US data, which was this one, and then I turned it into Racine confirmed cases as a CSV file. And I'm opening that in Excel right now, just so that we can look at it and see what that looks like, right? And the data in here, and I know this is probably a little hard for you guys to read, it's all on 2 rows, but it's two very long rows, right? You can see the top row is dates, and the bottom one is the confirmed number of cases total up until that point. And this is just for Racine. And I forget how I extracted it from the national one, but you know what? I can go in there. I still have the file available, so I'm opening that right now. It is a large file, and I want you to notice how long it's taking to open up. It takes a little while, right? It says convert large numbers into scientific notation. I don't want to convert to scientific notation. All right. So now I'm opening up the US data file, and I'm doing that on purpose because I want to show you, and once again, I'm going to zoom in a little bit here so you can see some of the data that we have, right? It is organized by state. So Wisconsin's way at the bottom, right? So we can kind of filter for Wisconsin. And you know what? This is where you might want to choose to use your filtering tools. Okay, so I'm going to kind of put that out there too. So I'm going to bring up my ribbon bar here, turn on the always show ribbon feature. I'm just going to highlight the whole table and turn on filters for every column. This just helps me sort. You guys see where I'm going with this? And then I'm going to clear all the selections. I'm just going to select Wisconsin. So now I'm just looking at Wisconsin information. And then, and you can see how long it takes, like every time I do a maneuver, because the data set is so huge. We're not dealing with a couple hundred entries now. We're dealing with thousands. So every little maneuver that you make takes that much longer. This is a lot of stuff in computer memory being manipulated. So the other thing that I'm going to do here is I'm going to look at, I assume these are counties, and how do I know that? Well, I'm highlighting all of them, and it says 74 counties. I think that's right. I thought Wisconsin had 72, but I could be wrong about that. So we can go to Racine County. So in other words, why don't we just come up here to the top then? And once again, notice how slow the data is kind of repropagating itself. And I'm going to deselect. I'm just going to select Racine. And I assume that's Racine County. State. All right, so this is Racine here. So this is all the Racine data on this line. And I want you to notice, what are the key pieces of data here that we're looking at? So if I'm going to make a chart, I already know from my filtering here that I'm looking at Wisconsin and I'm looking at Racine County, right? As I move to the left or right, yeah, I have latitude and longitude and whatever. But then we start getting really to the data. And you notice they started keeping data on January 22nd of 2020. And then this is the confirmed number of cases. Now, we already processed this data, by the way, right? This is where the data came from. And it's basically this data that I'm highlighting now that we grabbed, right? And it just keeps going on and on and on and on. And then what I did is I grabbed that data and I dropped it into this file, right? And so what this file is the boiled down version of that data. I don't have the county names and the latitude and longitude and all that weird stuff. It's just the date, right? And then the number of confirmed cases total up until that date, right? And then the data goes on. The data ends on March 9th, 2023. Okay, so that's confirmed cases. Now we want the deaths. Okay, so here's what I'm going to do. I'm going to close these files both, right? And the reason I'm doing that is to free up memory, right? And this is really kind of an important thing. And plus, I'm running a bunch of stuff on my computer, probably more than most normal people should. But if you have like a lower powered machine, you have only 8 gigs of RAM or only 16 gigs of RAM, these big files really impact performance significantly, right? And you guys will feel that. So I'm going to go back to our data set then, and I also need to get the number of deaths. So I'm going to go here, and then it's got a download button. So I'm going to hit the download, and now it's pulling down the download. It's already done. So here's the confirmed deaths. And I'm going to go ahead and I'm going to open that file. Now we're going to do the same filtering on this, and then I'll have my 2 data sets where we have deaths and cases, right? Okay, so let's follow the same procedures. I'm not converting my data. Yeah, it takes a little while to process it all. Selecting the whole sheet, turning on my filter tool, and then I'm going to do the same process here. We're going to start with the state of Wisconsin. We'll say okay, right? So this is just Wisconsin. And then we'll filter for Racine County. And there we go. So now we have the confirmed number of deaths. And I can just check here. This is January 22nd, same date, all the way to March 9th, right? And so all of this data here, and see, trying to select it, how much of a pain that is. Because I'm watching my scroll bar at the bottom right of my screen as I'm holding my mouse button down and how long it takes to select. There are faster ways with the keyboard, by the way. But I'm doing the mouse approach now. But I am grabbing all that data. Okay, and then I'm going to backtrack a little bit to here. I'm going to Control C to copy. And then I'm going to make a new blank workbook. I'm going to paste that data in. And then I'm going to do a save as. And I'm not really even sure where I saved it. I think it's just in my downloads folder. And I'm going to just start naming it Racine. So I'm going to kind of follow this format, but confirmed deaths is what I want to do. And you guys notice how taxing this is because now it's saying that Zoom is not responding. Can you guys still hear me?
Yeah, just the video is a little lagging.
So this video may end up being part 2. I'm not really sure if I can stitch it to the previous one, but I crashed in the middle of doing my demo on the assignment. We were basically working on this assignment. We had gone to GitHub to download the files that we need. and we have, we had already done the confirmed cases, and this week we grabbed all the confirmed deaths. It looks like it managed to save it. You guys catching that? The confirmed death file seemed to be captured. Let's open it up and see if the data is actually in there. So I'm hoping that it is, so I don't have to do the process again. Okay, and it is. Okay, so it looks like it's all there. And I'm just going to scroll all the way to the end. And I'm going to do a save as on this one, by the way. And I am going to save it to a CSV format. And doing a save. For whatever reason, it saves as an Excel file. So at least Excel saved it, right? So I didn't have to redo the work. But I wanted it as a CSV. And I don't know if you guys recall me doing this last week, but I wanted this data converted to a Python list. And I forget, last time, did I use ChatGPT to do this? Is that what I used? Do you guys remember? I don't recall if I thought maybe I used Claude. So I'm just going to go to Claude and see if it, nope. Oh, so maybe I use ChatGPT to do this. Yeah, CSV to Python lists, right? So all right, so you see, I'm just going to repeat this prompt. Okay, and you know what? I think I need to attach a file here. I think this is probably the easiest way to do it. And I'm doing this on purpose because I don't want to manually manipulate this data into a Python list, right? So this is like I'm showing you a great use case scenario for using AI. And you can see that it's analyzing. Yeah, and you know what? It is sort of working. It doesn't seem like it's doing it as elegantly. All right, so here's what I'm going to show you just to save time here, folks. Is I'm going to go into my solutions that I have already developed where I have some CSV files. And guess what? I'm going to share those with you since you guys are here in the session. And then you can use that data to kind of build your solutions as well. And I'm doing this in the interest of time as much as anything else. And so what I'm going to do is I have some of these files. I think they're already in my downloads folder. Yep, there they are. And I don't know if I can drop all of these into the chat, but I'm going to try to drop all of them into the chat and we'll see how that goes. And this is just to save you the task of doing that so you can also code along with what I'm doing. The grand point is I took all the data at one point in time, and I think this one's capped at an earlier date than the data that we were looking at. And then I use it to build the program that I'm about to demonstrate. Now, because these dates, and you know what, I'm going to open up the CSV file with the date range because I guess I'm curious how far that goes. Okay, so this is just the first 30 days of the pandemic. That's what I decided to do, or first 2 months, 3 months of the pandemic. That was, at least at that point in time, that's what my decision was. You could expand this out, right? But that's if you want to use a simpler data set. My grand point is you can use this instead. Okay. So the next aspect of it is starting to write the code. So let's get into a coding engine. I think what I'm going to use, I'm going to go ahead and use Spider today. I think most of us are comfortable with that, which is why I'm sticking with it. Normally I would say I'd force you to go to Jupyter Notebook. The one reason I don't is I don't like where it saves my files, and that's kind of a whole separate issue here. All right. Meanwhile, I am going to close all the open programs here. I've got a new one created. I'm going to go ahead and do a save as, and then I'm going to store it where I normally put my work for this semester. So this is going to be 10. And let's call this COVID data. So now we have the task of like writing a program that's going to process this like huge amount of data. And yes, I'm pulling up a cheat sheet here. And trying to find all this stuff here amongst all my examples on my other screen. So just bear with me. Oh, and that was part of one of the things that crashed here too. Okay, so I need to go to my downloads here once again. And I have these two sample programs that I was using. Okay, so let's start writing the code. And one of the first things I'm going to do is I'm just going to get rid of all the comments there at the top, zoom in, right? Pretty normal for my workflow. And we are going to be using the Matplot library. So the first thing you want to drop into your code is this. I'm going to be using Pyplot to put the stuff up on the screen. And then I want to choose what data points I'm going to plot, right? So this is where it gets a little bit interesting. So I'm just going to put a little comment in here for right now. Drop the data here, right? And so this is just kind of like a placeholder, right? So I'm going to have like a section here where I drop in all the data. Before I do that, I just want to kind of make this point about this data. When I put data into Pyplot, I'm plotting on an XY axis, and I'm really choosing to do basically a line graph to show the data points because I think it makes sense in this situation. And when I'm plotting on a graph, I really only need 2 data points for 2 dimensions, an X and a Y. Doesn't matter what those X's and Y's are, as long as they end up on one graph or the other. For me, the Y's are going to be the number reported, so the number of cases that happen. So those will go up the chart. And then the date will be on the bottom going across, right? So as we move through time, the dates will go from left to right, and the numbers in principle should increase as we go. Some of the stuff that we'll put into the application will be there no matter what. So just for example, I will have some listings, right? So the Y label will be the number of cases reported. The X label will be the date, right? And then I'll have a legend that will show both infected and deaths, right? And so this is kind of generic formatting stuff, which is why I throw it on the screen. Now, in order to kind of do some demonstration of the data, what I'm going to do is I'm also going to drop in a command for ticks. So this is where it kind of, we're throwing in some dates, by the way. So in other words, I'm not going to label every data point. I'm just going to put in a date every so often. So I'm going to put in a data point for, January 22nd and then February 1st and kind of every 15 days ish, right? And those are the ones I'm labeling. And it shows you what positions those are in the data. So I went through the data and I said, oh, this date's in position 1, this date's in position 11, this date's in position 25, etc. That's what those are about, right? These are just putting the marks on the lines of the graph. Next, we're going to throw in the data. So the reason I do this, and here's what's interesting, I can actually run this and I can look at it and this is what the output is. So just like really empty like this, it still creates the graph. You notice the dates and notice the numbers. Now, there are no numbers being reported. So the numbers on the left sidebar, it's like, well, I don't know what to put in there. So it just goes from 0 to 1, 0% to 100%. That's like the default. But now I'm going to start hard coding some data. All right, so here's, so if you guys are screenshotting, this is like your infrastructure in place right now. But the next thing that you want to do is you want to take your data and convert it to Python lists, and then take those lists and plot them on the chart. Okay, so here's how we'll do that. The data that I used last time, I don't know if this will fit in the chat. I'll throw it out there, but you can process your own data as well. Here's one Pyplot command. It looks like it fit. Here's the other Pyplot command. That also looks like it fit. So I'm going to just grab this data and then talk about what it is. Okay, so here's the first set of data. And here's the second set of data. And I think those are different. They are different. Okay, so I didn't, and I want to explain here what I'm doing. I am brute force adding a Python list. So a Python list is defined by values separated by commas inside of square brackets, right? So this highlighted piece is one Python list, and then comma, right? Another Python list. And what it is, this is the day of the pandemic, day 1 through 70. These are the confirmed cases for days 1 through 70. I think this is for the whole US, by the way. Right. Now, the reason I'm not going back to the data that I was filtering before, because you guys saw what it did to my computer. It crashed me, right? So I don't want to crash again. That's why I'm using a simplified data set here. The second listing, once again, days 1 through 70, and another list, the number of confirmed deaths. Notice the square brackets. Now, what I could have done, and I'm just kind of throwing it out there, I could have taken each list and saved it in a variable and called it, day of pandemic, for example, for that list, right? And the second list, I could have put it in a variable called confirmed cases. And then in place of those data sets inside the pyplot command, I could just use the variable name, right? This is brute force adding the data, right? The other approach, and I'll have you think about this, and this was the extra credit piece, is if you can get your data in the CSV file, you can read in the CSV file, drop it into a variable, feed the variable into the pyplot command. Either one would work just fine. Right? This approach you're seeing here is brute force or literal data injection manually. But I'm just giving you that because our main goal is really to get it on the screen. The other thing that I do want to do, and I didn't do this the first time, and I'm surprised it even showed anything on the screen, is, oops, I didn't type the command. I got to type it correctly as well to show it, right? To show the plots. Right, so I'm going to run this now, and then we'll see it on the chart here when it runs. But there we go. So this is the output. This is from the first 70 days of the pandemic. And real frankly, I don't remember if this is global or US or whatever. But the orange line shows the number of deaths. The blue line shows the number of infected. And this is the first 70 days of the pandemic. The lockdown, if you guys remember, the lockdown didn't happen until like the first week or two of March, something like that. And so if you could take the data of the number of, these are the cases, right? Those are the cases, these are the deaths. If you could drop the other data sets in there, you can see a more complete view of the entire pandemic. Once again, I'm not doing that because I don't want to crash my computer, but you could do that. So if you guys want to create a better visual, and I think real frankly, it would be a lot more impactful if you could show the whole duration of the pandemic. But I just want to show you the basics of how to make this happen. So really the Python coding part is really pretty simple. I mean, this is kind of it, right? A couple of Pyplot commands, importing a library, and then it's just feeding the data in. How you get the data in, that's kind of up to you. All right. Does anybody have questions about this or had any issues with this? I'm happy to answer them right here. All right, then I will cap this video. So this recording ends